In this video, I'm going to demonstrate some MC problems that appears frequently in DSE examination. Whoa. Question 50. Statement 1. Find the center of the circle. Now the equation of the circle is in general form. X squared plus y squared plus dx plus ay plus f equals 0, where d, e, f are constants. We can find the center by the formula negative d over 2, negative e over 2. We also have a formula to find the radius, that is square root h squared plus k squared minus f. H is negative d over 2, and k is negative e over 2, coordinates of the center. When you use these two formulas, make sure the coefficients of x squared and y squared must be 1. In this equation, d is negative 4, e is negative 8, and f is positive 11. To find the center, we put d is minus 4, e is negative 8 into the formula. So we have 2, 4. So the first statement is correct. Statement 2. To find the radius, we put h is 2, k is 4, and f is positive 11 into the formula. We get square root 9, which is equal to 3. So statement 2 is correct. Statement 3. To determine whether the origin 0, 0 lies outside the circle, we compare the distance with the radius. So the distance between 2 points is square root 2 minus 0 squared plus 4 minus 0 squared. We have square root 20, around 4.47, which is greater than 3. So the origin lies outside the circle. So statement 3 is correct, and we have 3 statements are correct. So the answer is D. We jump to question 54. The equation of a circle is 2x squared plus 2y squared plus 8x minus 12y plus 3 equals 0. Notice that the coefficients of x squared and y squared are 2, not 1. In this case, we need to take out the coefficient 2. Inside the brackets, we have x squared plus y squared plus 4x minus 6y plus 3 over 2. And then we divide both sides by 2. So on the right hand side, 0 over 2 is also equal to 0. Now the coefficients of x squared and y squared is 1. We use this equation to find d, e, f, and also the center and the radius. Statement 1. To find the center, we put d is positive 4, e is negative 6. We have negative 2, 3. So statement 1 is correct. To find the radius, we put h, negative 2, k, 3, and f, 3 over 2. We get square root 11.5. It is about 3.39, not 7, so 2 is wrong. 3. To determine whether 2, 3 lies outside the circle or not, we compare the distance of 2 points, 2, 3, and the center, negative 2, 3, with radius. So the distance of 2 points is square root 2 minus negative 2 squared plus 3 minus 3 squared. We have square root 16. It is equal to 4, which is greater than the radius, square root 11.5. So the point 2, 3 lies outside the circle. Therefore, statement 3 is correct. Since statement 1 and 3 are correct, the answer is B. We jump to question 58. The equation of the circle C is 2x squared plus 2y squared minus 4x plus 8y minus 5 equals 0. The coefficients of x squared and y squared are 2, not 1. So we need to take out the coefficient 2. Inside the bracket, we have x squared plus y squared minus 2x plus 4y minus 5 over 2 equals 0. Divide both sides by 2. We have x squared plus y squared minus 2x plus 4y minus 5 over 2 equals 0. Then D is negative 2, E is positive 4, F is negative 5 over 2. We can use these three numbers to find the center and the radius of circle C. Statement 1. To find the center, we put D is negative 2, E is positive 4. We have center 1, negative 2. Then we can find the radius. We put H is 1, K is negative 2, F is minus 5 over 2. We get square root 7.5. It is not equal to 5, so 1 is wrong. Statement 2. We find the midpoint first. Then we compare the distance of the midpoint and the center with the radius. To find the midpoint, we add the 2 x coordinates divided by 2 and 2 y coordinates divided by 2. We have minus 1 plus 4 divided by 2, 2 plus 0 divided by 2. We get 1.5 and 1. Then we compare the distance of the 2 points with the radius. And the distance is square root 1.5 minus 1 square plus 1 minus negative 2 square. We get square root 9.5. It is greater than square root 7.5. Therefore, the midpoint of PQ lies outside C. Statement 3. G is the center of circle C, so the coordinates are 1, negative 2. Now we need to find the angle PGQ. If this angle is smaller than 90 degrees, then it is an acute angle. Now because the 3 points P, G, and Q can form a triangle, we can find the angle PGQ using the cosine formula, which is PG squared plus QG squared minus PQ squared over 2 times BG QG. First, we need to find the three sides of these triangles. By the distance formula, PG is square root 1 minus negative 1 square plus negative 2 minus 2 square. We get square root 20. And then we find QG, that is square root 1 minus 4 square plus negative 2 minus 0 square. We get square root 13. Finally, to find PQ, we have square root negative 1 minus 4 square plus 2 minus 0 square. We get square root 29. Then by cosine formula, we substitute square root 20 to PG, square root 13 to QG, square root 29 to PQ. So by calculator, we get 0.124. So theta is around 83 degrees, which is smaller than 90 degrees. So this is an acute angle, so statement 3 is correct. So now statement 2 and statement 3 are correct. So the answer is D.